Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Raubensun, your partner in learning mathematics. In this video, we are going to learn about limit of trigonometric functions with lots of example. But before you click in this video, I do hope you already watched my previous video entitled Limit of Trigonometric Functions, Theorems, and rules, because it will really help you secure a knowledge in understanding examples in this video. Okay, so also I told you that you have to secure a copy of the trigonometric table of values. So this is my sample of trigonometric table of values, because before we solve trigonometric functions, let's try to read this table. So as you can observe, I have a radians in this column, and I have sine, cosine, tangent, and so on and so forth in this row. So let's try to see how are we going to read this table. This table is just like a multiplication table. You simply match what's in the column and what's in the row. Say for example, sine and pi over 6. So meaning, sine pi over 6 is equal to 1/2. Cosine pi over 6 is equal to square root of 3 over 2. And tangent pi over 6, that is square root of 3 over 3. Simple as that. Okay, so another one. Sine 0, that is 0. Cosine 0, that is 1. And tangent 0, that is 0. That's how you solve that one. That's how are you going to read the trigonometric table on. Okay, let's try this example number 1. My example number 1 is the limitation of tan pi as pi no, that's not pi, that's theta. Tan theta as theta approaches to pi over 6. How are we going to find the limitation of our tangent theta? So as you can observe, your theta approaches to pi over 6. As you can observe, if you watch my previous video, it simply told us to use the direct substitution. So the theorem says that the limitation of tan x as x approaches to c is equal to tan c. So meaning, you are going to simply substitute whenever your x approaches to your variable inside your trigonometric functions. Okay, same thing for example number 1. We simply use the direct substitution method in finding the limit of this one. So tan theta as theta approaches to pi over 6, that is tan pi over 6. So meaning, as simple as that. So how are we going to find the exact value of the limitation of this function for us to understand where this tan pi over 6 really approaches to? Let's go back to our table. This is our table, right? So let's find the radians. My radian here is pi over 6, and simply find my trigonometric function. In this example, I am using the tan function. Okay, so that is pi over 6, so that is pi over 6, and tan, so that is square root of 3 over 3. So meaning, tan pi over 6, that is equivalent to square root of 3 over 3. So therefore, the limitation now is square root of 3 over 3. That's how you answer that example. Okay, so now we are down to example number 2. Example number 2 states that the limitation of the quantity of sine x times cosine x as x approaches to pi over 2. How are we going to find the limitation? Same thing in example number 1. We use the direct substitution method in finding this one. As you can observe, I have here sine x and cosine x. Obviously, they are merged together, so the operation in between is a multiplication method. This is sine and cosine, same thing with what we did in our previous example number 1. We simply substitute that one. It will become sine pi over 6 times cosine pi over 6. Okay, again, this is a multiplication operation. So meaning we have to multiply that one. So second of sum, we are not done yet. We have to find the exact value of sine pi over 6 and cosine pi over 6. You have to go back to your trigonometric table and values. Again and again, my trigonometric table and values is limited. Okay, what I gave you is a complete set of trigonometric table of values. Okay, so let's try to find this one. Let's begin with sine pi over 6. Where is your pi over 6? And where is your sine? Sine pi over 6, that is 1/2. So meaning, this is equivalent to 1/2. Then you have to multiply that one to the value of your cosine pi over 6. So let's go back to the table. So that is cosine pi over 6, and that is square root of 3 over 2. So you have to multiply that one, square root of 3 over 2. Okay, so meaning the exact value of sine pi over 6 is 1/2, and the cosine pi over 6, that is square root of 3 over 2. So now what are we going to do is, since we already found the exact value of this trigonometric function, we have to apply what's the operation in between. And simply that sine and cosine is merged together, or simply the operation in between is multiplication, then we have to do multiplication. We believe that in multiplying fraction, we have to multiply numerator to numerator and denominator to denominator. 1 times square root of 3, that is square root of 3, and 2 times 2, that is 4. So meaning the limitation of sine x times cosine x as x approaches to pi over 6, that is square root of 3 over 4. So that is example number 2. Okay, so we are down to example number 3. This time, let's try some other trigonometric functions. So my example number 3 is, what is the limitation of the quantity of secant theta plus cosecant theta as theta approaches to 3 pi over 4? Okay, same thing. The trigonometric function still follows the addition rule, that you have to substitute the limitation in each term inside your function. So meaning, same thing with our previous example as well. You have to use direct substitution in finding the limitation of this function. By solving that one, it will become the limitation of this one is equal to secant 3 pi over 4 plus cosecant 3 pi over 4. Again and again, whatever here inside your where your theta approaches to, or your variables approaches to, you have to substitute it directly in all your variables. Okay, so after using the direct substitution method, you go back to the table that I gave to you, or that I presented to you. So here it goes. Okay, so meaning I have other trigonometric function, cotangent, secant, and cosecant. What my goal is to find the exact value of secant 3 pi over 4 plus cosecant 3 pi over 4. Okay, so here it goes. Let me fold this one. Okay, so now again and again, it is like a multiplication table. This is my secant here. Secant 3 pi over 4. Let me move here. Okay, so meaning secant 3 pi over 4 is equal to negative square root of 2. So it will become negative square root of 2. You copy plus sign. And now you go to cosecant 3 pi over 4. So my cosecant is over here. And 3 pi over here is 3 pi over 4. Cosecant, it matches to square root of 2. So plus square root of 2. So you already find the exact value in each trigonometric function. So that is negative square root of 2 plus square root of 2. That is exactly 0. So meaning the limitation of this function is 0. That's example number 3. Okay, we are down to example number 4. Still limit a trigonometric function. So my example number 4 is the limitation of tan 3x all over cotangent 2x minus secant squared x as x approaches to pi over 4. In this example, we are using the quotient rule. Okay, so before we solve that one, same thing. Okay, you have to substitute where your x approaches to, and my x approaches to is at pi over 4. But before that one, there are uncommon form of a function here. Say for example, secant squared x. What does it mean to have a secant squared x? Okay, when I say secant squared x, that is equivalent to secant x multiplied to secant x. That is not equal to secant x times x. Okay, they are different. So meaning every time you encounter that the power of your trigonometric function is at your trigonometric function itself, so meaning it is equivalent how many times you repeat your trigonometric function, not how many times you repeat your variables inside your trigonometric function. Again, secant squared x is equivalent to secant x times secant x, not secant x times x. Okay, they are different. So that's how you solve that one. Okay, so without further ado, let's solve this problem. Tan 3x cotangent 2x over secant squared x. Okay, so same thing that we did in our previous example. What are we going to do is to simply use the direct substitution where your x approaches to. So it will become, it is now equal to tangent, I have 3 here, 3 multiplied to pi over 4 all over cotangent 2 multiplied to pi over 4, and I have here secant squared multiplied to pi over 4. Okay, so now we already substituted where our x approaches to. After that, you have to simplify this one. So it will become now 3 times pi, that is tangent 3 pi over 4. All over, it will become cotangent. We believe that we can able to simplify 2 over 4, and that is 1, 2, and this is, we have the remaining 2. So that is now cotangent pi over 2. And this is now minus secant squared pi over 4. Okay, so we already substituted that one. So after you substituted that one, we are going to find the direct value or the exact value of this following. So based on the table, please look at your table. When the value of tan 3 pi over 4, that is equivalent to negative 1. That's great. Okay, again, you refer to your table of values. Okay, that is negative 1. And the cotangent pi over 2, that is equivalent to 0. Okay, minus, you copy minus sign here. Now, what is the value of secant squared pi over 4? How are you going to find the exact value of those trigonometric function? Simply, you disregard first the squared, okay? Then after that one, you go to your secant in your table, or secant pi over 4. Again, secant pi over 4, that is equivalent to square root of 2. Okay, so since you have squared here, you are going to put the squared after you find the value of secant pi over 4. Okay, again, how did I get that one? You first disregard squared here. So you first find the secant pi over 4, and based on the table that I gave to you, secant pi over 4, that is equivalent to square root of 2. So why did I put squared here? Because I have squared in my second. Okay, am I clear to you? Okay, that's great. Okay, so after we find the value of these following terms, we have to simplify. So it will become now negative 1 over, we believe the square root of 2 with the another power here, we can able to cancel square root of 2, right? So negative 2 times 2, that is negative 2. And we believe, and let's extend over here. Okay, so now that is now negative 1 over 2. So negative divided by negative, that is positive. Therefore, the limitation now is positive 1/2. Okay, so again and again, after we put negative 1, we can able to cancel it out. The remaining value now is negative 1, copy. The remaining value here in the denominator is negative 2. Why? Because we already canceled out square root here because we have a power of 2. So 2 times negative, that is negative 2. 0 minus 2, that is negative 2. So we are done with that one. So after that one, we continue simplifying. We all know that negative divided by negative, that is positive. So that is positive 1 over 2. Therefore, the limit of this function is 1/2. Okay, we are down to example number 5. Still limit at trigonometric function. So for example number 5, I have here the limitation of cotangent 2x all over cosecant cube x plus tan 3x as my x approaches to pi over 3. Again and again, the first step that we are going to use is we are going to use direct substitution method. Meaning wherever your x approaches to, you have to substitute that one in all the variables. So it will become now cotangent 2 times pi over 3 all over cosecant cube pi over 3 plus tangent 3 times pi over 3. Okay, so you use the direct substitution method in solving your first step. Okay, second step is that simplify if there is something that needs to be simplified. Okay, so very obvious, we can able to simplify tangent here. So it will become cotangent 2 pi over 3 all over cosecant cube pi over 3 plus, in this part we can able to cancel 3 because 3 divided by 3, that is 1. So 1 times pi, that is now tan pi. Okay, so we already simplified everything. So actually this is now the limitation, but we want to see a clear picture, a crystal clear picture to what is the exact value of this following trigonometric function. Again, after you simplified everything, you go back to your trigonometric table and values. Okay, so based on your table of values, you check your table of values. Cotangent 2 pi over 3, that is, let's proceed over here. Okay, so now cotangent 2 pi over 3, that is equivalent to negative square root of 3 over 3 all over, what is the value of your cosecant pi over 3? Again, every time we encounter a trigonometric function that is being powered to any value, so meaning you disregard first the power. You go here, cosecant pi over 3. What is cosecant pi over 3? That is 2 square root of 3 over 3. Since I have a power of 3 here, I have to put all the values in the power of 3. Okay, you copy plus sign plus, what is tangent pi? Based on your table, tangent pi is equal to 0. Okay, so we already found the value in each trigonometric function, and these are now the values of your trigonometric function. After you find the value of your trigonometric function, you have to simplify that one until such time everything is clear to you. Okay, so very obvious, if you're going to add this one, still this one, because this is now 0. As you can observe, this is a double fraction. Okay, this is a double fraction. So again and again, how we simplify double fraction? First is we copy the numerator. My numerator is square root of 3 over 3. You change division sign to multiplication sign, and you get the reciprocal of your denominator. So meaning I have to interchange numerator to denominator. It will become now 3 over 2 square root of 3 raised to the power of 3. Okay. So, again, you copy numerator, you change division to multiplication, and you get the reciprocal of your denominator. Okay, reciprocal, interchange the position of numerator and denominator. Afterwards is you follow the rules of fraction. But before that, you first look at this one. This one is under the power of 3. So, but before you proceed to that one, you have to get the simplified version of this part. Okay, so first you copy this one. This is square root of 3 over 3 times 3 cube. What is 3 cube? 3 cube is 27. All over 2 cube, that is 8 over 3 cube. So we can write it 3 cube. Okay, so we already find the simplified version of this part. So this one being raised to 3 is equivalent to this one. Okay, so after that one, we have to continue simplifying this one. So I don't have any so I have to erase this one to continue answering the problem. Okay, so let's continue over here. So let's write this one. So that is negative 3 over, square root of 3 over 3 multiplied to 27 over 8 divided by 3 cube. Okay, so let's continue simplifying that part. So we believe that 27 divided by 3, we can able to divide that one. Okay, 27 divided by 3, that is now 9. So the remaining here is 1. 27, cancel, the remaining now 1 is 9. In layman's term, you simply divide 27 divided by 3. That is 9. Okay, so 9 times negative square root of 3, that is negative 9 square root of 3. Okay, so in your denominator, you have 1 times 8 square root of 3 cube. So 1, so meaning the itself. So that is 8 square root of 3 cube. Okay, so again, what you did here is you simply simplify that one. So what is the remaining now is this one. So continue simplifying. So as you can observe, in this version, we can able to simplify your denominator. Meaning, we can able to write it this way. So 9 square root of 3 over 8. Since the power of your denominator under the radical sign is cube, so that is 3 squared multiplied to 3. Meaning, 3 squared times 3, that is 3 cube. Okay, so we can able to simplify it that way. So, continue simplifying. Very obvious that the 3 squared, meaning we can able to find the root of 3 squared, and that is 3. So, meaning it will become negative 9 square root of 3 over 8 here. 8. So, what is the square root of 3 squared? That is 3. So, meaning multiplied 3 here. So, what is the remaining now is 3. Okay, look at this part. So, meaning, as you can observe, we can able to cancel square root of 3. Let me erase this part. Okay, so we can able to cancel that one. Let me write it again. So, what is our new form now is negative 9 square root of 3 over 8 times 3 square root of 3. Again, why it become like this. Again, 3 squared. 3 squared is 9. What is the square root of 9? That is 3. So every time you find the root of any number, you have to multiply it to any number outside the radical sign. So how it goes. So as you can observe, square root of 3 divided by square root of 3, we can able to cancel that one because we have multiplication as operation. So cancel it out. So what is the remaining now is negative 9 over 8 times 3, that is 24. Okay. Very obvious, we can still find the simplest form of this number. So meaning, the simplest form of this number is that negative 3 times 3, negative 3 times 3, that is negative 9. And this is 24 is equivalent to 8 times 3. 8 times 3 is 24. So we can able to cancel 3. What is the remaining now is negative 3 over 8. Therefore, the limitation of this example number 5 is negative 3 over 8. As you can observe, kinda long. You have to review the algebra needed, most especially in finding the root of a number and simplifying fractions. So in this example, the limit is negative 3 over 8. Okay, that ends example number 5.